Today we're going to build the Tower of Math Knowledge. Math begins very simple. It starts with counting. And you might think that counting is no big deal, but if you go to a 3-year-old and ask them how many fingers this is, they can't just tell you 5. They have to work on it, and they might get lost somewhere between 1 and 5 and forget what comes next. It takes practice to learn how to count, and some people can learn to count with just a little bit of practice. Some people need more. But anyone can get this bottom foundation block nice and strong in their math tower. Next, we have inequalities. You need to understand that some numbers are bigger than other numbers, and some numbers are smaller. So we have a nice little alligator mouth that we use to represent inequalities, and it always goes toward the bigger number. You also need to understand place value. This one's a big one. You need to know that in the number 1024, each digit has a specific meaning. In this number 1024, the 1 represents that there is one group of 1,000. There are 0 hundreds. The 2 represents that there are 2 tens, and the 4 represents 4 ones. That's place value. If you don't understand place value, that makes addition and subtraction a big headache. So it's important that every single block is in place so that you can build on to the next one. After addition and subtraction, we get multiplication and division, which is just like adding and subtracting, but we're doing it fast. And while we're learning multiplication and division and addition and subtraction, we also do graphs. That's representing mathematics with visuals, like pictures. You have fractions. When you look at fractions, you're looking at just the part of a whole, and it's also another way to think of dividing. Exponents are a lot of fun. They're a really cool way to multiply. 5 to the third means 5 times 5 times 5. And with exponents, our numbers can get really big really fast. Trigonometry and geometry, study of shapes and angles. And then we have algebra, which is kind of like a puzzle. If I say what's 2 plus my secret number that will give me 5, when you figure out what that secret number is, you just did algebra. And last on our Tower of Math Knowledge is calculus and statistics. The reason that I have this as the top block is not that it's the last step, because it's not. And do you want to know a secret? All the fun math, the really fun math, starts here and it keeps going. There's lots of other math you can do after calculus and statistics. But the reason this is at the top of the tower is because this is the tool that will unlock science. Math is the key to science. And if you have calculus and statistics, you can do amazing and incredible things in science. I'll give you a couple examples. Let's say that there was a really big lake, and you wanted to find out exactly how many fish are in the lake. Well, how would you do that? You could get a boat and go fishing, right? And try and catch all the fish in the lake. But that wouldn't be very nice, and it wouldn't be very practical either. How could you ever know that you had caught all the fish in the lake? There might still be some swimming around down here that you never caught. So let's talk about what we can do with statistics. This time, go fishing, catch a small number of fish, and tag them with either a little mark on their fin or some sort of thing so that you can recognize them again. Then you let them go back in the lake, you let them swim around with all the other fish, and you do a second sample. And this time, you would compare how many fish you caught had the tag and how many fish didn't have the tag, and that would give you a much more accurate idea of how many fish were in the lake than trying to catch them all. So let's go back to our little guy here. You'd give him a couple buckets, something to mark the fish with, and with the help of statistics, we would be able to figure out how many fish were in the lake without ever having to catch them all. Pretty neat, huh? Now calculus. Let's talk about what we could do with calculus. Say there was a prince who had a room at the very top of a really tall tower with a really narrow, crooked staircase. To find out the biggest couch possible without calculus would be really hard. You would probably have to carry 20 different couches up and down the staircase trying to see how big you could get before one got stuck. But using calculus, you could find out the answer just with math. Calculus is really good for finding maximums. It's also really good for finding area. And this is cool. Finding the volume of a cube is easy, right? We just kind of do volume, by height times width, and we're done. But what about a really weird-shaped Hubbard squash? These are real, by the way. They're blue on the outside and orange on the inside, and they taste delicious. If you wanted to find the volume of a Hubbard squash or a watermelon or something else that was shaped really weird, You could do it with calculus. You can find the volume of any type of three-dimensional shape with calculus. So those are just a couple of the amazing things you can do with calculus and statistics. And like I said, they are the key to science. If you can do those two types of math, then you open the door to all sorts of amazing discoveries and possibilities. But there's a reason this tower is a math tower built like this, because if you take out any of these lower blocks, then you can't get up to the top. So let's pretend like when I was going through school, I got to multiplication and division, and I just thought, oh, it's hard, I don't want to practice, I don't like it. Let's find out what happens if I try and take this block out. I'll try and do it fast. Oh, that's what happens when you don't get those fundamentals in place. So remember, practice is what gets that block securely in place, and if it's secure, then you can build on top of it and get up to the really cool fun math that's at the top.